On this parabola, we have a strange form. It's called standard form, actually. And we notice that x is the variable being squared. So this is an up-down parabola, but it's hard in this form to find the vertex and focus and everything we need. So since it's an x squared parabola, we should get it into this form. X minus h squared equals 4p times y minus k. This we can easily extract the vertex from and p. So here's how we do that with standard form. Start by getting all the x terms on one side of the equation. So we'd have x squared minus 4x. I'm going to leave a space right there, and we're going to move this negative 12y and negative 32 to the other side. So there'll be 12y and positive 32. Now on this side, what we're going to do is complete the square. What could we add to this side to make this a perfect square trinomial? The way to determine that is cut the negative 4 in half, that gives you 2, and square it, and you get 4. So if I add 4 to this side, I have to add 4 to this side to keep the whole equation balanced, and we end up with x squared minus 4x plus 4 equals 12y plus 36. This process is called completing the square, and there's other videos that explain that in detail. But what that allowed us to do is get this perfect square trinomial. This trinomial here factors as x minus 2 quantity squared. And over here we can factor out a 12. So we get 12 times y plus 3. And actually, we've achieved the form we were looking for. From this, if we compare it to what we were going after, we can see that h is 2, because that matches with the h. K is negative 3, because this says y minus k. So the number you'd have to put here would have to be a negative 3 for it to appear as a positive 3 down here. Finally, the 4p matches with the 12. So the value of p is 3, since 3 times 4 would give us that 12 there. Here's what this tells us. First, the vertex is located at 2, negative 3. So let's transfer that over. 2, negative 3. We also know this is an up-down parabola because it's an x squared parabola, and we see the value of p is 3. Since p is positive, we know this parabola points up. And we also know the focus is going to be 3 units up from the vertex. So that would get us to 1, 2, 3 right here. The coordinates of that point are 2, 0. To find the directrix, we go 3 units down from the vertex. 1, 2, 3. So right here. So the directrix is at, let's see, that's y equals negative 6. The axis of symmetry always runs through both the vertex and the focus, so it's right here. That's at x equals 2. Now to graph it, here's what I would do. Looking at this, I see the more general form, the non-translated form of this particular parabola is x squared equals 12y. Basically all I did is drop the h and the k, because all the h and k are doing is shifting this parabola 2 units to the right and 3 units down from having its vertex at the origin. So this parabola right here would have a vertex at 0, 0. It'd be right there. Our parabola has a vertex down 3 units and 2 units over. But here's what we can do. With this parabola, we can find some points, and then we can shift those points so they represent our parabola. Looking at this side, a good value for y to plug in would be a 3. Because if we plug in a 3, 3 times 12 is 36, and the two numbers we could square to get a 36 are negative 6 and 6. So this parabola would have the points negative 6, 3 and 6, 3 on the graph. Let's go to negative 6, 3. Negative 6, 3 is right, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3. This would be on our simpler parabola, but what we need to do is shift this right to 1, 2, and down 3. 1, 2, 3. So here is the point negative 6, 3 shifted to be on our parabola. Now the other point we had was 6, 3 on this simpler parabola. So if we take the point 6, 3, and if we also shift that point 2 units to the right and 3 units down, we'll have another point for our parabola. So 6, 3 is right here. Let's see. 1, 2, 3, 4, 5, 6, 3. We need to shift it 2 units to the right, 1, 2, and 3 units down, 1, 2, 3. So here's another point on our parabola. Connecting those 2 points we got to our vertex, we have the following parabola.